Okay, so this is number 27 in section 2.5 on page 101 in your book. And we're given a Venn diagram. And there's a little paragraph above that says that this Venn diagram shows the number of elements in region 5. So notice region 5 is the intersection, right? So there's two elements in there. That's the cardinality. And you want to use this cardinality and the given cardinalities to determine the number of elements in each of the other 7 regions, right? So this is 1, right? 1, 2, 3, 4, 5, 6, 7. And I counted that using regular natural numbers, not the actual Roman numerals. So remember that after entering the cardinality of the innermost region, which we already have, basically you're just working your way outward, and you're basically going to use subtraction to obtain subsequent cardinalities. So, think of survey subtract, if that's a helpful reminder to that you're going to repeat subtraction problems. So what do we have? Okay, so let me just write a couple of this information down. And the cardinality of the universal set is, okay, so we should have 30 elements. The cardinality of A, we should have 11 elements. The cardinality of B, we should have 8 elements. The cardinality of C, we should have 14. And then we have a couple of intersections. So the cardinality of the intersection is 3, and then we have 5, and then of course we have 3. So again, remember, we're given the intersection, right? This cardinality, there's 2 elements in here. So we want to work outward, right? It doesn't matter if you start with 2, oh gosh, is that 4 or 6? That's 6, that's 4. But it doesn't matter which region, how you go outward. So I'm just going to look at 2. Well, I know from the intersection of A and B, so the intersection of A and B, right, the cardinality is 3, meaning I should have 3 elements in here. Well, if I have 2 elements in here, then 2 plus 1 will give me my 3. So I know, and let me maybe put it in, let's see, let's see, black. So this should be 1, right? The element 1 is in there in region 2. So you can say, okay, check, I use that. So now what about A intersection C? Well, A intersection C, okay, here's A, and here is C. Okay, so what's the intersection? Okay, obviously we have 2, but what's the cardinality? The cardinality is 5. So 2 plus what is 5, right? Or 5 minus 2. So this guy has to be 3. So let me just write in the 3 there. Okay, so then finally, let's see, let's check that. So the intersection of B and C. So the intersection of B and C, right, again, is this region right here. And again, all this should be 3. So 3 minus that 2 is just 1, right? So all we did was subtract our value minus 2, right? We're just subtracting this guy. Or again, 2 plus what is 3, so that's got to be 1. So I'm going to write a 1 in there. So now we have our inner regions. Okay, so now we just move outwards. We want to see how many elements are in here, right? In 3, meaning here, and then in 7 here. So let's see, check. Okay, so we're given n of A, right? Or the cardinality of A is 11. That means there should be 11 elements in set A. So here's set A, right? So we have so far 3 plus 2, right? So that's 5 plus 6. Well, 6 plus what, right, gives us 11, and that's got to be 6. So let me maybe just, I don't know, use a different color. So there's 6 elements there. And again, you can check, right? I mean, 6 plus 3, that's 9, 10, Oh, wait a minute. 5, 6 plus 6 is 12. That is not right. That should be a 5 right here. Let me just erase that. Okay, it's not letting me erase again, but that should be, right? Make sure to change that to a 5. Okay, so that's done. N of B, so the cardinality of B, so it means that this whole set, right, should have 8 elements. So 2, 3, 4. Well, 4 plus what is 8, right? This should be 4. So this is 4, and check. And then finally, we have the cardinality of C is 14, so that means that this set, right, should add up to, it should have 14 elements. So there's 3, right, plus 2 is 5, plus 6, plus 1 is 6. So 6 plus what gives us 14? So this guy should be 14 minus the 6, which is 8. So I will put 8 in here. And finally, we want to find, right, how many elements are outside, right? Or in other words, in the complement of A union B union C, right? Which is out here. So it's basically, well, we're given, let's see, maybe. So we're looking at this guy. This is the last one. So there should be 30 elements, right? And all of the universal set. So let me get my little pointer. So we just add all these up, right? Or in other words, it's 30 minus the sum of all these numbers. So, well, let me just use a pointer. So this is 6, 9, 10, 18, plus 4 is 20. Oh, wait, let's see. 6, 7, 8, 9. Oh, I forgot the 2. 5, 6. Okay. 7, 8, 9, 10, 11, 12, plus 8 is 20, plus 4 is 24. So all of this adds up to 24, and we have 30 elements, so it's just 30 minus 24. So let me get maybe a blue. So this is 30 minus 24. So there are 6 elements outside of A union B union C. So that's how you fill in the other 7 regions. Again, you want to start with the innermost and then go outward to the smaller regions and then finally to the last larger regions.